Okay. So today we can start Docker, right? All of you.
Sure.
Fine. For the newcomers, anyone have any idea or anyone worked before Docker environment or new to these terms, right? Of you. Okay. So, before Docker, where actually our application deployed, it's in a local machine, right? Or in a virtual machine or a physical machine. Okay. So I will draw a simple diagram how it's look like. So for example, the requirement is deploying a application. Okay. For this is pre-Docker. Okay. So we have to buy a server. Okay. So this is a physical or virtual machine. Okay. And traditionally, this is a physical bare metal machine. Okay. Physical machine. Bare metal. There is no hardware. That's why we call it bare metal. Only hardware. So in top of the bare metal, we install a virtualization tool. Okay. That is the VMware. Then on top of the VMware, we installing different type of operating system, Windows or Linux, VMware. This is a hypervising software. Okay, hypervising our local host machine to multiple virtual machines. In this case, these all the machines are virtual machines. Okay, VM for the host machine. This is a host machine. This is another VM like Red Hat. This is Ubuntu. We can install as per the requirement. We can install corresponding machine and we can deploy it application on top of the top of each operating system. So for each machines here, they need resources like CPU and memory. So that will be shared by the host actually. Okay, for host, it's have like 12 virtual CPU. So whenever we configuring each OS, we can allocate corresponding operating or resources to each machines. So memory is 64 GB like that. Okay, this is a simple example because this is a server actually. Okay, the server have a lot of resources. Okay, here a lot of issues are there. Like for example, here you can see we run an operating system here and here and here, right? For running an operating system, that's fine. On top of the operating system, we will install. I mean, we deploy our application. So this is an app actually. App. This app related to Ubuntu. Similar like Red Hat. Okay. Final thing is we need to deploy application on top of each operating system. But in this method, the problem is here we can see a full operating systems running in between our application and virtual machine VMware application, right? For running a simple application. See, for running an application, that application need only the application dependency, libraries and framework. Libraries, binaries, and framework. That's fine for running an application. But for that, here you can see we install a full operating system here. So that operating system take a lot of storage. Okay, storage in the sense of if we need to install a full operating system, we need to take at least 4 to 5 GB, right, for Windows. That's the image size of the operating system of Windows. So storage is one concern. The main thing is there are a lot of other services running in the operating system. Okay, so that has application. So that services need CPU and memory also. So that much resources is utilizing. Okay, we can't utilizing that much. So in this case, here we facing resource utilization issues. Okay, resource. Okay, that's one of the main thing coming to this scenario. Then if this problems actually cost as well. Okay, so if the resource is high, then we need to pay more cost. But actual for running an application, we need like a small resources like one core or 1 GB RAM. Okay, as per the application requirement. But in between, we need to spend a lot of resources for each operating system. For the Windows or the Ubuntu, same as for the Red Hat. Okay, what are the resources? Because these all the operating systems are full operating system, full OS. Got it. Any doubt? Okay. Now this is one of the simple high level setup of before Docker. Okay. Then coming to Docker, how it's overcome these resource things. Okay, for the CPU, memory, storage, everything. So coming to Docker, if we need to deploy application using Docker, we need a server, right? So we need to set up the server. So this is a bare metal or a VM virtual machine. Okay. Mm, on top of the virtual machine or bare metal, we need to install a operating system. This is a full operating system. Okay, a OS. Here we can see like we install a virtual VMware tool. Okay, that tool is virtualizing our host machine to different multiple client machines or virtual machines. Okay, so here we install a operating system. And then on top of the operating system, we install Docker. Okay, we called as this service as Docker engine. Okay, that's fine. Then on top of the Docker, we will deploy application. So this application one app app three like that. Got it. And this is called Docker container. So this is a container one, container two, container three. Okay. You don't have any doubt regarding the architecture of Docker? No doubt, right? Okay, fine. Then okay. So coming to Docker, okay. So what is Docker actually? Docker is actually open source platform, okay, where we are going to deploy applications. It's a virtual environment Okay, here you can see these are the containers actually. Okay, container one, container two, and container three. This is actually a like a virtual environment. Okay, or a separate environment where we are deploying or running our application. That's container actually. Okay, for running a container, we need to create a container configuration file actually. Okay, so that configuration file is like a text file that contain some instructions. Okay, we called as Docker file. Okay, so using Docker file, you can run Docker container. Okay, and coming to the features like Docker can automate the deployment. Okay, scaling and management of application within lightweight. Okay, here you can see each containers are lightweight actually here. Okay, that I will explain later. So these containers package an applications dependency framework, libraries, binaries, and all things. Okay, so these all things ensuring that application inside the application is running fine and okay. Then each container in Docker environment, each container is a standardized unit. Okay, a standardized unit software, and it will run isolated in between each container as well. So this container is isolated environment, this is another isolated environment, and this is third container is also isolated environment within this Docker engine. So I will write some briefly, okay, coming to Docker part. Okay, and this is our base machine. And on top of this is the VM or a physical machine or a bare metal. On top of that, we install operating system. This may be Windows, okay, Windows or Linux as well. Linux, anything we can install. Then on top of this, we install Docker. And on top of the Docker, we deploy our application. So we call it as Docker container. App 1, app 2, app 3, like that. Okay. So actually, coming to the previous example, okay, like uh, in pre-Docker setup, you can see we installed different operating system actually, and on top of the operating system, we deploy our application, right? So that each machine is taking a lot of resources, right? Because that machine has some other services as well that we don't need that service actually. Actual thing is we don't need a full operating system, okay? That's the main thing. So coming to Docker container, okay, I will open this Docker container, okay, so you will get more idea. So I will take this container, okay. For example, this is a Java application. Okay, consider this is a Java application running fine, but I will take that Java application. For creating this Java application, we need to write it from scratch, okay. From scratch, we need to write a Docker file. Okay, first thing is we need to create a Docker file and include all application dependency libraries. Then all things we need to define inside the Docker file. Okay, we can use Docker instructions when coming to Docker file. So there are a lot of instructions are there. So we need to learn the instructions. Then we created the Docker file. That's fine. Then we need to install the Docker. Okay. Then after we need to build this Docker file. The second stage is Docker build. These all things we need to do for creating this container, okay? Then after building, we will get a built image. build image. Okay, build image is nothing. It's contain a metadata. Okay, for the applications dependency, all things it will wrap in a single image. Okay, that's all. So that image contains everything related to the application, and that is a I mean, if you run that build image, it will create a container with the application. That's all. So here we will get a build image. So take that build image and we can run the image. So for that, we need to run Docker commands. After installing Docker, okay, we need to run Docker things using Docker commands, okay. Docker commands are there. So using Docker command, Docker run, we can run this build image, okay. So after building, it will create container like this, container app. So these are the things that we need to do. First, we need to create a Docker file. Then we need to build the Docker file. So we will get a build image. Then we need to take the image and run the image. So it will create a container with our application. Got it? Any doubt? Okay. So the next thing is after the container is deployed, okay. I mean, after running the image, okay, it will create a container. Estimate time. Give me a second. Okay. So I will open one of the container. Okay, so we'll get more idea. So this is my container. Okay, application container here. So I will take this container. Okay, the Java application. So coming to the container. Okay, what are things inside the container is hey, for running a container, that container needs a base image. Base image. So what is base image? Base image means whenever coming to the container environment, okay, that container needs a minimal operating system that is called a base image. So we need to define the base image whenever we creating the Docker file. Got it. So coming to the Java application, okay, base image means a minimal operating system. Okay, so here we can see after the VM we install a operating system here, right? This is actually a full operating system, full OS. So coming to the Docker container, we need to set up a base image. So base image means a minimal operating system. That operating system leverage some basics. I mean Linux operating systems features. Okay, something called workspace, user workspace. Okay, user workspace. Some features that base image will get. Okay, like we can run apt or RAM You can see some root files as well. So these are the binaries. Okay, these are the some basic binaries are coming to the base image. So that's all the things included in the base image, and the size also below, like in between 100 MB to 200 MB or 300 MB. Like that's the maximum. We can select as per the size of different types of base image. Okay, when writing the Docker file. So coming to full operating system, that operating system have a lot of services, and the size of this operating system is 2 GB to 4 GB in between for Linux case. Got it. So the first thing is base image. Then we need to define the application dependencies. Then application code. Then what are things that we need to define, like coming to the container. Okay, this is actually a like a virtual environment. Okay, so we need to open the port number as well, because we are running a Java application here. So we need to expose the Java application from container. So we need to expose the port as well. Expose the port number. Okay, for example, 80 or 8080 like that. So these are all the things that we need to include inside a container with the base image and the dependency for application and the application for everything we need to define. Also, we can log into this container as well. Okay, we can log in from our local machine to the container using exit command, and we can see everything there. For example, we are going to deploy a web application. Okay, in previous case, you can see we deploy a web app directly to a VM, right? So what are the things that we do? Like we run some commands in. First we log into the virtual machine, right? So we got the terminal like user EC2 machine. Okay, EC2 user. So this is a working directory of this machine. So from here we perform some commands. Like first we need to install some dependencies for exposing this web application. So we need to install web server, right? Web server. So we run that command from here. So we will get the download the web server Apache. Then the second command, same working directory, we will run systemctl restart the same app service like Apache or HTTP. Then the next step is we need to move the code, right? We have an application code. So we need to move the code to the directory. After installing Apache, it will create a directory that called var www html. The var directory is there actually. It will create only www html. Okay. So we need to come inside the HTML and create the file, or we need to copy the index.html file or any other files related to the application index.html. So fine. Then we deploy our application. Okay. That's okay. So coming to the if we do the same application deployed using a Docker container, okay, we run the Docker container and we expose the container. So after we log into the container, we can see all these things actually there. So we can go to the user or user var HTML directory. We can see the application there. Similar way, here all the things are there. That's why we call it base image contain some features, minimal features are there. So we can see the root path, we can see we can run yum, or we can run apt, and we can see the directory as well. So that's all included in the base image. Got it. Any doubt? So the application running in a virtual machine, we know, right? The steps. For example, The steps include first we need to install Apache, right? Second, we need to enable the Apache, or we need to restart the Apache or starting the Apache service, because whenever we installing the Apache, it will not active state. That's why we're using systemctl command to enable that service. Then after we need to go to the directory. This is a directory, and we need to keep that. Copy the application code index.html file under the HTML directory or folder. Okay. Then we need to go to the virtual machine security group to enable or open the port number 80, right? Because using this is HTTP application. Okay. Sorry, this application using HTTP protocol. So we need to open the HTTP protocol port number 80. So that users can access the application using the port number, right? So this is the steps, okay? One by one steps that we need to perform, deploy a sample web application in a EC2 machine, okay, or a virtual machine. So coming to Docker, okay, Docker environment, we need to do the same things, but for that, we need to create a Docker file and define all these steps inside the Docker file. So after, whenever we're running the Docker file or building the Docker file will taking all the responsibility, or that's called which it will automate the deployment process. Actually, what are things that we need to define inside the Docker file? It will automate this process. Okay, this step-by-step process. Got it. So I will show you one sample symbol Docker file. Okay, for the application deployment. So first we need to create a Docker file using Nano or Vim. Then I told you, like, coming to Docker file contain a lot of instructions. Okay, the instructions actually, whenever we building the Docker file, the Docker actually looking for the instruction that we define in the Docker file. Okay, so instructions, how we define Docker file is uppercase. Okay, all the instructions in Docker file we need to define as uppercase. So first we need to define, coming to a Docker file, we need to define the base image, the base image. So we need to write like the instruction from. Okay, this is a instruction that we using for a base image. Okay, that we define a base image in Docker file. This is actually a Docker file. Okay. So coming to the base image, we need to define Ubuntu, or like I will go with the Ubuntu. Okay. So what will happen? We need to define the version as well. Okay, after the image name. So whenever we building, okay, the Docker file looking for the from instruction, and what are the image that we define the from instruction. So it will download, okay, or pull the data for the base image from Docker Hub. Docker Hub is a native cloud central repository for Docker Hub. Sorry, Docker actually. Okay. So Docker Hub. So we can see a lot of official images are available in Docker Hub. Also, we can create a Docker Hub account and we can push our own images, okay, to the Docker Hub. So in this case, it will looking for the Ubuntu image. Okay, we need to define correctly actually the name and everything. So it will taking that, pulling that image from Docker Hub. Okay, image for the base image. Then the next thing is we need to, what are things that we done for the web application in local machine? Same thing we need to define here under as instruction. Okay. So with that container got a base image, right? So the next thing is we need to run, install the Apache, that thing we need to do, right? Okay. So for that, we need to use a run instruction. So run instruction, after the run, we can type the name or type the command. Okay. So that will run that command inside a container. So we can use apt or yum install HTTPD or Apache or whatever service then we need to do, then we can define here, okay, and run instruction. Then next thing is, so now it's installed, okay, consider like that. We Apache we are running inside our container is fine. So next thing is we need to copy the application. So we can use copy instructions. These are the instructions actually, okay. Native instructions for Docker. So we can use copy instruction to copy some files from our local machine to local machine means our virtual machine, okay, to the container machine. So this is a format actually, okay. Local space container or local path space container path. Okay. For example, I'm copying the index.html file, okay. If that index.html file in some other directory, we need to define the path, or else same working directory, then we need to define the file name only, okay. So I will using the file, consider I'm using my index.html, my local, working directory. So I just need to define the file name, HTML space, then the container path, okay. For where we are going to keep the index.html file in container or virtual machine, the same directory, var www HTML. So that we can see the index.html file in container path under the same path, okay. So in this instruction, the Docker file or the Docker looking for the file index.html file in the same working directory of the virtual machine, okay. In this case, this is a virtual machine, and it will take the file and copy to the container path, this path. So that's the process. Then we need to code is moved to the corresponding directory. Then we need to open the security group, right? Coming to virtual machine case. So coming to container case, we need to expose support using expose instruction. Expose. So using expose instruction, we need to define the port number, okay? For example, 80. So the container port 80 will open. Got it. So if this application is not JS or any other application, we need to open corresponding port, okay? Then the final thing is CMD, okay? CMD or entry point. Entry point is nothing. Whenever this container start, okay, this container start, the first thing will start, okay. For example, in this case, we can ensure, okay, we can ensure that whenever the container start, first thing is starting the service, the HTTP, I mean the Apache. So in similar case, okay, we can define that service name under the entry point. So the entry point format is entry point format, executable, then arguments. This is a format, okay. So we need to define the executable file, okay. In this case, Apache is the executable file. Actually, that Apache executable binary files belongs to some directory, okay. So the directory is user, I think user has been, yes, user has been. Then the name of that file, I mean HTTPD. Okay, so this is the default executable file belongs to the HTTP. I mean, whenever we install the Apache, it will create a binary file and it will keep in the spin. Okay, user under the user profile, there is a spin directory there. So inside directory, we can see the binary. So we need to define the path, the same path here as executable. This is a format. Okay, executable. Then the arguments, we can define the arguments also. Arguments means, for example, we need to start the Apache service whenever container start and it will run in background. Okay, for that case, we need to define the execute argument as well. For example, D foreground. This is the argument, okay, foreground. That means it will run background, the HTTP. Got it. All of you. So anyone have any doubt?
What was the D foreground? That's the program. So you expose the port, then you had what was the entry point?
Entry point ensure that whenever the container start, the HTTP service also started. And it runs as in a background mode. So the container is run, I mean the HTTP service running in background actually. So that thing we need to define under the entry point. Got it. More.
So the service is running on the entry point, and then the foreground background decides whether it's running in the foreground. Then the command prompt is occupied. If it's running the background, the command prompt can.
Right. Anyone have any doubt? Okay. So okay, one more thing I will add here. Okay, we don't have much time to go to the lab. So I will take some more theory related to the Docker. So coming to the Docker, okay, coming to Docker, Docker also need CPU and memory, right? For example, here we have some application container. Okay, this is a container. Okay, this is a two application container, consider like that. Container two. So I told you these machines have a minimal operating system, then only it's contain the application dependency and everything to run the application inside the container. So rest of them it's not taking, okay, for unnecessary service not running inside a container. So that these machines or these containers need minimal resources for running the application. So that all things shared by the host machine actually. We have a host machine, right? Host. So by default it will share the memory and resources network to the container, okay, from the host. This is operating system, okay. And one more thing it will shared by that is the kernel of this host machine, okay, kernel. So these all things shared by the host machine to the container for working smoothly. CPU, CPU, memory, network, these all things by default is sharing. Otherwise, if we need to, I mean, for example, we have to deploy an application, that application need at least 500 milli of like RAM or CPU like that, then we can define that also whenever we are running the content. Okay, that's a customized version. So this is the normal default sharing of CPU and memory from the host to container network also. Then one more thing is volume, Docker volume. So what is Docker volume? Docker volume is, for example, we have running containers here, right? So for example, consider like that we have a database here, okay? Database container. So we need to store that application, okay, the data persistently, okay. So we need to keep the persistent data. Then we need to go with the Docker volume. Because, for example, the container is deleted or stopped, okay, or removed, deleted, console like that deleted. So if we did not configure the Docker volume, our data will lose, okay. Whenever the container is deleted, the data also lost. Otherwise, if we created a Docker volume and mapped it to the container, then after deleting of the cache residue container, our data will be saved in the host machine. Got it? Host machine. For that, we need to create a Docker volume using Docker command. Docker create volume. Then the volume name. So we can see typing Docker volume ls. We can see the volume that we created. Then we need to mount that volume actually with the container. Okay. For example, then we need to create a Docker container for the database. So at that time, we need to attach that volume or mount that volume. Docker run. We use a flag -p for mounting or mentioning the volume. Okay. Then we need to mention like the volume name, my volume. This is a command to run application. Okay, container application. Volume. This is where we need to mount it. Okay. Then the container path. For example, the database files belongs to the container path app. Okay, consider like that app directory. So that's fine. So what are the things it will create in the container app directory? So the same data will be seen in the local machine, my data, my volume. This volume we created in actually in the local machine. Okay. So we can see the data, volume, data, everything in the local machine as well. So when coming to lab, I will show you okay how to create volume and how we will mounting the container for persistent data. So in this case, the container is lost or deleted. The data will be here. Otherwise, actually, for container data, actually by default it will be in the host machine. Okay, so we can see the when we go to the directory, we can see the data here. But if we deleted the container, the data will lose. Normal case. Similar way, Docker network also there. Docker network. But why we creating Docker network? We need to separate some application container. Okay, so we need to create a separate network when coming to Docker. So Docker create network name. So it will create a network. So we can when we deploying similar like this. Okay, deploying container, we need to define the network path as well. That's all. So that application, for example, we need to deploy 3 containers. Okay, sorry, 2 containers for an application. So that application we need to keep in separate network. So whenever we're running that application and mention the network, so that both container will be belongs to the network that we created. So we can isolate the applications. So that's why we creating that Docker network. Do you have a doubt?
What does the Docker network point? You said why we create a Docker network.
Consider like by default, coming to Docker, by default, there is a network actually. Okay. Whenever we creating, installing Docker, it will create a network for our applications. The containers that we are going to create. So some concern are there. We need to keep a separate network and we need to keep some application within the separate network. So for that, we need to create a separate network within the Docker. So we use Docker network. And the application deployment goes to the corresponding network as well. So in this case, we can isolate our applications. For example, we have 3 clients. Okay, so the best way is we need to create separate 3 network inside the Docker. and deploy the application, recline application to the different network. So we can ensure that all the application is isolated, even the network isolation happen here. Got it? It's a network isolation.
So each Docker container is like a sort of like a separate computer once its image is running, right? So they are all separate, but they can talk through the ports with each other. So that's what you're referring to as a network.
Right. But we are not called it's a computer or a small minimal computer for a container. Actually, it's a environment. Actually, it's a it's a environment where the application is running. That application, yeah.
Somewhere it's a Linux process, basically. It's a Unix process somewhere.
Right.
That has all the data, but it's in its own compartment.
You're right. Only we need to keep that application dependency to run that application. That's all.
Dependency means all the other softwares that it needs.
Right. For
correct versions of all those softwares.
Right. For example, the HTTP web application, the dependency is web server, right? Without a web server, we can't expose we need to expose our app. We can't expose our application, right? So that application need a web server to serving the web content.
So then that web server will be in the Docker network.
Right.
Okay. I got it now. Thanks. I don't know if
anyone have any doubt? Otherwise, we can wind up today's section, right? All of you. So tomorrow we will go with the lab section, okay? For the same, like creating Docker network, creating volume, and we can deploy some application using creating a Docker file like that. Okay. Then we can wind up, right?
Okay, thank you for the lesson. Good morning, Tawfiq sir. Good evening to everybody on this side.
Okay, bye. Bye all. Bye.